Hello. In this video, we are going to discuss a scenario with a potential mistake you can make while using the auto level. This we want to avoid. Now this is best explained as an example. So let's imagine you're in the field. It's time to hoist the cables, so you mark the F values for each cable position onto the abutments. You're training the auto level on the first of these values from a nice flat area on the other side of the river. From here, you'll easily be able to view the cables for hoisting and pan over to the marks on the tiers. So I have a wonderful photo or diagram drawn for you here. The marks would be, say, on this abutment here on the left. And, I've drawn out the dimensions, the potential dimensions that we would see. So let's consider this scenario for an 100-meter bridge. And because the bridge span is 100 meters, we can approximate that you're about 120 meters away from the tiers as you're sighting it by standing off to the side over here, of course, wearing your hard hat. Now, using this, we can reverse the auto level horizontal distance formula here of the upper minus the lower stadia hair times 100 equals the distance in meters that you are away from the object you're sighting. And to achieve a 120 meter distance, you must see a differential between the upper and lower stadia hairs of 1.2 meters. This is almost 4 feet. So I've put some example numbers to it for you, and the range of vertical distance in your auto level sight is now going to be almost 1.8 meters or 6 feet, which is quite large. So keep that in mind. And now let's consider a scenario for a 40-meter bridge. Another beautiful photo or beautiful diagram I've drawn. Because the bridge span is 40 meters, we can approximate that you are about 50 meters away from the tiers as you're sighting by standing off to the side. Using this, once again, we can reverse the auto level horizontal distance formula. And to achieve a 0.4 meter distance, you must see a differential between the upper and lower stadia hairs of 40 centimeters. This is only about 1.3 feet. So the range of vertical distance in your auto level sight is going to be almost only 0.6 meters or 2 feet. And I've put some numbers to it here for you again, and this is quite small. All right, so now this may seem obvious after going through the previous thought experiment, but the main lesson learned is that the auto level horizontal distance calculation is a ratio. Vertical distance depends on horizontal distance. Now, the vertical distance between the center crosshair and either of the stadia hairs is never a fixed value. You can see in the diagram below. The angle from the center crosshair, which is at perfect horizontal when leveled correctly, to the upper and lower stadia is fixed. So as you move the auto level toward or away from the point you are sighting, distance, or lowercase l, in the graphic here changes. So the other side of the triangle formed, or h, uppercase H, in the graphic here must change accordingly. But be careful. The main lesson is to be careful because using the stadia hairs to approximate vertical distances will always depend on how far you are away from the object you're sighting. And I've done a short derivation here for you, just to show that if you were to have everything leveled correctly, you'd have your value here as upper minus lower divided by 2. If we're looking at this as a right triangle, you'd have our distance here to be u minus l times 100. And then we can calculate our angle theta to be fixed because when you do the arctan of these two distances, you see that we have the u and the l cancel out, and our theta will always be the same.